this computer. So how many of you had the opportunity to peruse the videos or textbook this week? Right, the content for this week is fairly short. We're going to be doing, so my plans for the week are as follows. Today we are going to be working on reviewing some more turtle functions. So because we've got chapter 3 and chapter 4, which are fairly straightforward. It's all about debugging. It's how you import things. Oh, right. I have to do the attendance. So yeah, that was the other thing I want to mention. Because of the pain that attendance has been in terms of just everything, first off, don't worry about your attendance. First off, attendance doesn't matter. It really doesn't. I'm doing it because I am at this point, the only reason I'm still taking attendance is because I'm mandated to do so. And until such a time as that doesn't happen, yeah, and because of all the headaches I've had with Quickly and multiple sections being served at the same time, because I'm like one of the only people who has that issues, I'm just going to simply have it so everybody checks in for the lab. And if you don't have lab that day, then you'll get marked absent, and that's okay. And I'll simply change the message to be something more passive-aggressive about how the Quickly system is a horrible system. So don't worry about it. Again, literally the point of attendance is just because, well, it doesn't have a point anymore. It's mandated. So starting the check-in for everybody, and it should go. Should start. All right. That being said, because of the way, so now with that, because of the way that, you know, this happens, generally it happens earlier in the semester, but with the Monday off, the format of lectures now follows this, or the format of content now follows the following format. Tuesday, Thursday, lab for students on Friday on that stuff on Tuesday and Thursday, lab on that stuff Monday. So the labs on Monday will now be going over the stuff that had been learned on Tuesday, Thursday, if that makes sense. So at least that's how it's going to work for this week. Otherwise, it just wouldn't be fair. And I've done that in the past, and it works. I don't like it, but it works. Simply put, keep up with the due date, and just remember that as far as this class is concerned, Tuesday is the start of the week. Now, so we're going to be dipping a bit into chapter 4. So let's go. I'm going to go ahead and, yes, you'll be able to demo after class today. So first, let me start off by sharing my screen. Okay. And I was looking for some good assignments to do, but I'm just using one of the other ones I have, which I realized it was a good time to do it. So module 3 is debugging in libraries. Should really rename it at this point because it's expanded beyond that. So here we've got some videos on debugging, some videos on how to import in Python. And then I said, read by Wednesday these two chapters. Yeah, reload the page. It's going pretty slow. Again, attendance is all made up. Points don't matter. No, the entire point of attendance is that I'll use it to keep track of basically the last time somebody was in class, and that's about it. And so then the lab and reading for next week will be these turtle exercises. And I said, do that by the 14th. So that will be for this, and this will help you with this lab. Now we're going to go over that stuff for today, which is all about turtles. Today we're going to be talking about how computers draw circles. And then on Thursday, I'm going to teach you guys how to do, I'm going to go into detail on how to do for loops. That's also going to be covered next week as well. But this is a material I figure that is worth doing 2 passes on, once by yourself and also out being introduced, because it is just so crucial for students to get this. And I really want to make sure you understand this. So let's see. So yeah, but we're going to be learning about how for loops and how mathematicians calculate pi. You're more than welcome to bring pi to the lecture on Thursday. So yeah. Let's see, so stop sharing for now. Okay. So any questions about this week's content, or do you want me to also introduce what you've got to do for lab for this week? There is no quiz this week, by the way. Okay. Share screen. Yeah, I completely forgot about showing you the lab, so I just figured I'd mention it. All right, so the lab is my turtle loops program. It's, I think, 5 problems on turtles, and you will need to use loops to solve them, but fairly straightforward loops. So first and foremost, do not name your homework turtle.py because doing so will result in 0. This is because, as I explained in the videos, one of the most common issues we see with students is that they will, let me make sure the game's all the way turned up. Okay, so one of the most problems I see common problems I see that students have is that they name the file that they're working in turtle.py. And as I explained in the videos, if you try to import turtle.py, it will import itself, which just doesn't really give you any of the commands you need. So you'll want to name it like turtle loops or something like that. So problem 1, Turtle Olympics. Basically write a program or a function if you know how. You can write a program or a function for each of these if you know how to do functions. If you don't, just put them in separate files like we've been doing. Write a program which uses a turtle or turtles to draw the Olympic ring logo. Extra credit if you can get the rings to overlap and cross over and under correctly. Okay. The turtle clock basically creates something that looks like a clock. It should resemble something like this. This will utilize the stamp function as well as the pen up function. Write a program that draws your initials. Write a program that draws a shape, specifically an n-sided regular polygon, which is a lot more complicated than it sounds, but essentially it's a polygon so it's a shape with n sides and all the sides are the same length. So an equilateral triangle or a square or an archetypical pentagon, like the kind of pentagon you imagine when somebody says pentagon. Same with hexagon or octagon. So this one is possibly the toughest, but it is not actually that tough. And finally, 5, draw the Triforce symbol using turtles. Okay, each problem of these problems is worth 20 points with 10 extra credit points on the Olympic problem. These are not particularly hard. A lot of stuff, so I think pen up and up are the same. There's a lot of commands like write and RT, which basically duplicate functionality in the turtle, like forward and FD. So that is what we are, that's what we're looking at. Now, let's go ahead and double check when this is due. I set it due for the 17th, which means that you've got until next Thursday to submit it, right? So in other words, right before, not this lab section, but the following. Is each problem in separate files? That's generally the easiest way I've found to do it. If for testing purposes, if you know how to do functions, you can do it in functions as well. I will be available on Friday and on Monday to answer more questions about this. If you need help with this. But today we're going to learn more about how to get started and more about how to do for loops in the context of turtles. On Thursday, I'm going to be talking about we're going to be talking about how to use for loops in the context outside of turtles, as well as talk about patterns such as the accumulator pattern, which are very common in Python. If you're unable to demo today after lecture, you can still demo. Yeah, demoing. It's important. The important part is the turning in part, and then demoing afterwards. Demoing. All right. Okay, thank you for. Okay, so let's talk about today's project. So, so tomorrow won't have a associated, Thursday probably won't have an associated project. Once we go over sequences and repetition, we'll go over password generation, which is fun. So let's talk about drawing a circle with a turtle. So first off, if you remember, we were talking about pixels a couple of weeks ago, right? Pixels, right? So no, I don't want a 2015 film, pixels. Okay. I want pixel as in picture element, right? And the idea here is that if you look at your screen, you'll notice that that basically a computer displays an image by rendering individual pixels, small little images on your computer, small little squares that get set to a certain color. For instance, if this on the left is the image on your computer, if we were to get in close, you would see this is what it looks like when we zoomed in. It's all jagged in. Or it's all jagged. So it's a mix of picture and pixel or picture element. So there are different intensities for it, but the point being is that if you think about it actually, yeah, this S looks nice and curved. This P over here looks nice and as a nice curved circle. All right, let me go ahead and check. So I'm getting reports of stuttering. So, all right, please go to the participant window. Click on the bottom, hit participants, or top maybe if it's screen sharing, wherever the participants is. Click on participants, hit yes if it's working, no if it's not working. Yes if your connection is good, and no if you're stuttering. This will let me know if it's my problem. Okay, so for the vast majority of people, this seems to be working fine. For the vast majority of people, this seems to be working fine. Maybe I'll experiment with Google Meets one of these days. So, no, please no. Why have people had poor experiences with Google Meet? I'm guessing there are horror stories behind the messages I am seeing saying just no. No, I don't want to. No, the thing about Google Meet is that you don't download anything else. It's purely in the browser. I just learned to Zoom. All right, understood. I understand. All right, so the point being is that all of these images that you see on the computer are jagged. And that we have basic, and there's some features such as anti-aliasing that go on to make things look really, really clear. But, you know, there's really no way we can draw an actual circle there. So the question is, how do we do it in Python? Well, like how would I write code to do it? Yes. Hello? All right. If you've got a question, then please put it in the chat. That is the easiest way. If it's urgent, you can break in, but otherwise put in the chat. All right. So let's go ahead and work on this function, this first function. All right. First, ask the user for a side length and let's draw a triangle. Okay. So we're going to build up to a circle. So so what is the first thing we should do if we're working with turtles?
Import turtle.
Yep. All right. that's not going to do anything for us, but other than just simply tell us that we want turtle to run. And yeah, there's no issues going there. What's the second thing we need to do to work with turtles? We have to make a turtle, right? So what is the code to make a turtle?
Name a turtle?
Yep. So I've got it. So we create a variable, whatever we call it, and then we type in turtle dot turtle. And the mechanics behind this and what this does we'll go into more detail in chapter 5. But what we are doing here is that this first turtle means the turtle package that we imported, and then dot, and then this will say something inside the turtle package, and now this is the command to make a turtle object, which is a representation of the turtle. So if we save and run this, we should get, let's see, anything? Nothing yet. So next, let's go ahead and just try this out and test our code. Alice.fd for forward, or maybe just do forward 100, which will move Alice forward 100. And there we go. We've got our code there. Do you have to name the turtle? Why is there a space between the import and the name? Because if there wasn't a space, it would just simply be read as import turtle. Import is like a line space, aesthetics, readability. So over here, let's see, I'm just making sure I didn't miss a question. I am sorry that, Ryan, that everything is frozen for you. See, yeah, and now Ryan also asked, do you have to name the turtle? No, you could technically say turtle dot something, but honestly, gets confusing. I personally prefer to name my turtle and put it in a variable, because it helps make things more, because it's actually possible to make multiple turtles. Bob is equal to turtle dot turtle Bob dot backward 100. And we run and we'll see, save and run. Here we go. We now have 2 turtles on the screen. Dude is very short and easy and reminds me of Finding Nemo. So, anyway, we've got Alice here. So now the next thing it says is that we want to ask the user for a side length and draw a triangle. So we can ask the user via the input function. Okay, so let's go ahead and say side is equal to input. And we'll ask, please enter a side length. All right, so let's go ahead and now let's say side is equal. So this will take a string and store it inside. Now remember, since we're dealing with strings and we probably want a number, we'll go ahead and turn it into an integer after that. Make sense to everybody there? I'm taking in a string and then I'm going to store it in an integer, print, and then I'm going to confirm that everything went okay. Print side. Save and run. Please enter a side length, let's say 100. And so it printed out the variable, which is good. So now what we have to do is that we want to draw a triangle with that's whatever length the person told us, right? Rather than using a solid number like 100 and 100 and 100. Is there any reason not to do it on the same line? Because it gets scary for some people. Meet posted in chat, as well as a bunch of other people. Can't we do just this? And the answer is yes, but for pedagogical reasons, I often break it up into 2 lines. And readability is, it's always important to keep in mind readability because remember, the person who wrote the code last week is an insane person who had no idea what they were doing and didn't document anything. So making it readable is always very important. So now for blank in, so actually let's stop. I'm not gonna skip over to there. Let's go ahead and do, now let's make our 3 sides. So we got to have the turtle draw 3 sides. So Alice needs to move forward the side length. So let's say whatever that is, we're going to go 100. Okay, no problem there. And now essentially, so if we think about how to draw this turtle, go and grab a whiteboard. No whiteboard. Okay. So if we grab a whiteboard, let's go ahead and create a new whiteboard here. So, right, what we need the turtle to do is, it's easiest if we move forward. I said nope. Why is it not doing that? Okay, you were working just a second ago. There we go. Draw forward. Right, so there's an approximate line. I'm pretty terrible at drawing, but okay. Then we need the turtle to turn and draw a line there. And then we need the turtle to turn again. And draw a line over here. So here's the thing. Here's where your geometry lessons may hurt you slightly. All right. So how many degrees does the turtle need to turn right here?
120.
120. 120 if we're going to be drawing it as an equilateral triangle. Now, if somebody said 60, you'd be wondering what's going on here. The reason being is that this angle over here, right, we've all learned from our classes that the internal angles of a triangle are, they add up to 180 degrees, right? That's totally what it is. So this would be 60, 60, 60. Well, yes, but a 45, 44, a 45, 45, 90 is harder to draw. So, however, your turtle is facing this way, right? If your turtle is facing this way, we need to turn, we can either turn left or right. So in order to make the turtle face this way, we need to we need to turn basically 120 degrees, which is, right, which if we take 180 minus the 60 out, we'll get 120. Right, because remember, turning fully this way would be turning 180 degrees. We don't want to turn that much. We only want to turn up to this point. And yes, once we do 3 turns, 120 plus 120 over here, plus 120 over here, plus 120 over here, will add up to 360. So, does everybody understand why I'm turning 180 degrees? Oh, sorry, not 180, 120 degrees right here. Again, the internal angles are what add up to 180, but since our turtle is doing the drawing, we need to turn the amount that the external angle is. The external angle being, if we extended this line, we need to be turning this angle. So Alice dot right turn. Yep, right turn for going for the downward triangle. Ah, silly. Okay, that was interesting. Load history. See, I'm not immune to making silly mistakes like that. It's very important that you understand that even people who are experienced make tons and tons of mistakes. So turn right 120. And so let's go ahead and draw 100. And now you can see that the turtle has turned this way, so it's ready to move down. Now, this is a triangle, so we are just going to copy paste this 3 times. 1, 2. Well, we've copy pasted it so it existed 3 times, which means pasting it 3 times, or pasting it twice rather. So now it goes forward and turns, forwards turn, and forward turn. Right? Everybody understand why we did that 3 times? Okay. And if you're not understanding it, but don't want to admit in front of the class, you can always private message me, which is just to select me from, it's just to select me in the chat and send a message that way. Right? Did we really need that last turn? That is an excellent question. And the answer is no, but it's useful for consistency's sake, and it also puts us exactly back into the starting position. What if you wanted to make another triangle on the triangle? Well, I'm not going to do your homework for you. So if you want to make, basically if you want to, okay, yeah, if you want to make another triangle on the triangle, you can. So now, again, so as I mentioned a couple last week, I believe, copy pasting things a lot of times can get quite tedious. So instead, we have the functionality to repeat certain lines by using what's called a for loop, which is of the current form, which is of the format in Python. For, in, and you can put anything you want there. So I'm actually just going to put for turn in range 3. And then basically you indent whatever you want to happen inside of that for loop. Whatever you want to be repeated 3 times here, you indent it inside the for loop. That's how the for loop knows it's that it's part of the for loop. So for instance, if I do this, we will first import turtle, create the turtle. It's going to ask me, please enter a side length, 100. Turn it into an integer for us, and then repeat the following stuff 3 times. Move forward, turn, move forward, turn, or turn. What if you want to make a pentagon? Spoilers. We're going to move up to that. Is the default I? The default is typically I. So for those of you who are coming from different programming languages, you might be familiar with the for int I equals 0, I is less than blah, I plus plus loop, right? How many of you familiar with that? Plenty of you? Yep, C++, Java, C, they all use that kind of loop. Okay. Python doesn't have that loop because reasons. Instead, what they have is this iterator loop, which mimics this. What I wrote here, so this up here and this over here are essentially equivalent. Those 2 lines are essentially equivalent. There's some finessing that Python is doing, but essentially those 2 things are equivalent. In Java, for them to actually be exactly the same, it would basically, there's a for each loop. in Java, which, for instance, might look like this. Int num in array, and that exists in Java. So Python, some of the stuff we do learn here is compatible with Java. But what's important for everybody to understand is that this thing, if you just see for whatever in range, then this means whatever's indented inside it will run 3 times. So notice that done prints out exactly once because it was on line 12. If we move it around and indent it inside this for loop, it will print out 3 times because it will move, print out done, move, print out done, and move, print out done. Is I a variable? Yes, it is. We are going to go into more detail about those variables after this exercise. Does that make sense to everybody? So, now is like kind of the important thing to understand about Python if you're coming from a different programming language, because if you're not coming from a other programming language, you're just going to do it correctly instinctively. But if you're coming from another programming language, it's important to understand that Python really cares about your white space. So, for instance, doing something like this, notice it automatically errored on me. It says, no, you cannot do that. Indentation matters. Similarly, doing this, see how many times this runs. 3 times, because it's technically inside the for loop. It's been indented inside of here. So whatever's inside the for loop is indented. You can think of the indents acting like this if you're coming from something like C or C++ or Java. I is the name for a variable. We don't really, but if you don't care what the variable is, you can just put an underscore. And you'll find that this is very powerful, the for blank in range or the for blank in whatever. What matters though, the most common mistakes I see for a student is leaving off the semicolon, or leaving off the colon, rather. All right, so I'll go ahead and share this code with you, with all my students. So if you reload that page, it will probably be, you'll be able to see it. So does the for function, yes, the for function automatically ends once it detects, I'm not sure if it ends on line 12 or line 11, but basically once it says, oh, there's no more white space, once it says there's no more stuff indented in me, it won't do anything. So now let's go on to the next stuff. So now that you've done this, now that I've shown you how to do it for this, let's all take 5 minutes. I'm going to split you up into breakout rooms, and we're going to take 5 minutes, and you are going to do it now for a square. So do the next problem. Make a turtle, draw a square of a given length. Shouldn't take too long because you have the code for a, you should have the code, by the way, for this. If you don't have it, reload the page. So let me do that. Nope, that is not what I meant to do. Reload the page. And then simply load history. There should be an option over here to load it. But I shared it to all of you. So I'm not sure what that looks like on your end, but you should be able to see it over here. And then you can use that as a base to create the square. And if you're getting adventurous, you can do the octagon. Okay. So let's go ahead. I'm going to Sorry. Just logisticating. Okay, so hopefully that wasn't too bad. Right, does anybody want to go ahead and share their code with the class? Any victims, I mean volunteers?
I can.
Okay,
Indeed.
go ahead and hit share screen on the bottom. All right.
There. Yeah.
So we see here we've got import turtle. Dude is equal to turtle.turtle. Asks for the side. So it's exactly the same up until the line 7 over here, which says rather than 4i in range 3, it says 4i in range 4, right? Because squares are 4-sided shapes. So dude then moves forward whatever amount we put in, then turns right 90 degrees. Because squares, you make 4 turns, that adds up to 360 degrees. So 360 divided by 4, that's 90. But also we know that squares are made up of right angles. Okay? So do that 4 times and we get that. So let's go ahead and actually, let's terminate the other screen sharing because I want to move on to the Octagon, but I see that some students have already been able to solve that. Using the participants yes, no tabs. Tell me yes if you already moved on and solved the Octagon. So a good bulk of the class has, so that rather than splitting you up into breakout rooms again to solve that, I'll go ahead and walk through the solution for the Octagon in front of everybody. Sound fair? Okay. So let's go ahead and I will share my screen again. Stop sharing. I want to share my entire desktop. Oh. Okay, there we go. So let's go ahead. So we've got ourselves our Octagon over here. Ask the user for a side length and draw an octagon. So we can just simply copy paste what we had over here at the beginning. So Alice is equal to turtle.turtle. Set up a side, ask the user for a side length, input it, and now we know that octagons are made up are 8-sided shapes. So it makes sense that we would want to do a for loop to repeat a code where we move and turn 8 times, right? Squares are 4-sided shapes, we did it 4 times. Triangles are 3-sided shapes, we do them 3 times. So let's go with 4 blank in range 8 because we want to repeat what we're doing 8 times, right? So whatever we're going to do, we're going to just repeat it 8 times. So obviously we want to move forward. We want to use the same code we were doing over here, which is asking my turtle, which is Alice, to move forward the appropriate amount of space. But then comes the question of how much does Alice need to turn, right? I could try to draw an octagon, but I'd utterly fail, right? So an octagon, though, is, as somebody said, 45 degrees. To turn, we want to turn 45 degrees. Now, let's go ahead and see why that. And notice that we started with 120, and then for the square, we were doing 90. And then for the octagon, we're going to go down to an even smaller turn. Alice dot right 45. Now, how did we arrive at 40? Now, how did you arrive at 45? Because that is the correct answer. Although It does go out of bounds as far as the canvas is concerned, but this turtle still does draw. So somebody said 8 times 45 is equal to 360 degrees. And this is so, we've noticed that if we do, somebody said square has 4 sides, octagon has 8, so 90 divided by 2. Excellent logic over there. So divide by 360 by the number of sides, right? Because when we did the triangle, we did a number of right turns that add up to 360. Incidentally, 360 degrees, that's the number of degrees in the circle. All right. So I think people are starting to see the pattern, right? So, and what's cool is that a circle, if we think of the circle as being perfectly round, we can't, as I was mentioning earlier, we can't really do that on the computer screen. So we're gonna just draw something that looks circle-ish. And you've probably noticed that if we would make this a bit smaller now, let's go ahead and make this 50, that our octagon looks much more circle-ish than a square does, which looks more circle-ish than a triangle. Okay? So what we're going to do is that we're going to draw a circle by having a turtle make a polygon with a lot of sides. So to make the leap to drawing an approximate circle, we need to figure out how many sides we need, how long those sides should be, and how much to turn. 360 sides is a lot, but you probably don't need that to do 360 degrees, because your eyes and your computer probably don't need to be that exact. But you can but depending on the order in which you enter these questions, you can probably end up with something very different. So experiment by asking the user for a radius, then draw a circle with that radius. So that's a bit trickier. We're not asking you how long the side is. We're asking you how long the circle is. Okay, and now here's the kicker. So if the circle is of a certain radius, if the user gives us a radius, how big do we need to make the circle? What is the circumference of that circle? Well, we learned that formula in math. 2 pi r. So you're going to want to use that formula and the fact that you get a radius to basically be able to draw a circle of the appropriate size, something that's not going to be ginormous. That's my suggestion to you. So this is what we're going to be doing for the remaining 25 minutes or so. Ask the user for a radius, then draw that circle with that radius. And then if you can do that, ask the user for a radius. Then here's the other one. Ask the user for a radius, then draw a circle with that radius, but make the center of the circle at the current location of the circle. So how do you use the pi symbol? So I think somebody asked how to land and type the pi symbol. Well, the way I always type the pi symbol is that I copy paste it. But if you want to use the built-in Python built-in value pi, you can use import math and do math.pi. That's covered in the videos for this week, which you didn't have to watch for this lecture. But you can always use 3.14, or if you want to be more exact, 3.14159, I think would do it. Or you can use, as we'll learn, approximations of pi. You can use this, let's see. You can use this formula, let's see, where is it? You can use this ancient Chinese formula of 355 over 113, which is pretty close to pi. So we will be talking about what pi is in more detail, but you'll be wanting to use it. So, okay, go ahead and get started. If you can do that, this part, then try this one. Or if you're more comfortable and you want to just jump to this, ask the user for a radius, then draw a circle with that radius, but make the center of that circle the current location of the circle. Would you like me to split you up into breakout rooms at this point to work, or do you all want to work here in one large group? All right. So I will basically check in every so often. Let's go ahead and clear the results. Once you are done with this, please let me know by hitting the yes button for participants. Go ahead and get started. I didn't have them. All right. So somebody says they are lost already. So you think you need to poop?
Yes.
Annie? Could you all, so somebody very clever said, pointed out, can we just use the circle function? And the answer is, yes, but it would defeat the purpose of the exercise. And what we're doing is recreating the circle function. So, all right. So let's go ahead and give it 5 more minutes. And then I will go over and then I will basically redirect things. So just try to think, about it some more. I highly recommend here's my hint to you. Start by drawing a 20-sided shape. Try, instead of trying to draw a circle, aim to draw a 20-sided or a 100-sided shape. The radius thing is the tough part, but I'll help you with that. The only input we care about is not the angle, but the radius. Could you use circle? Yes, but it would defeat the purpose of the exercise. Give it a couple more minutes and I'll go over this for everybody. So I'll add everybody who's, so once it gets to 3 o'clock, I will go over it with everybody. This is a bit of a big jump. So don't worry, don't feel too bad if you're having trouble getting it. Nice. if you're already doing fine, just go on to the bonus one. The bonus one is for if is basically is essentially a reach. If you can do it, then you can do it. What does at the current location of the turtle means? That means basically draw from your starting point. You're going to the center from location 0, 0. You want the turtle to draw it. Yeah, that's right, Ethan. What's the code for lifting up the pen again? Pen up. I'm not sure why. Why you get an attribute error on that. Try pen up, Chloe. Hey, janky circle is fine. That's right. Yeah, alice.penup or something like that. All right. All right, so I'll go ahead and get started on showing you how to do this. So many of you, let's go ahead and make sure I'm recording. So many of you may have had your first taste of, let's call it existential despair for computer science. This feeling that you are not cut out for this, or that you are having, or that you're having trouble. I regret to inform you that that feeling is going to keep with you for a while. I also regret to, but I am relieved to tell you that it is a completely normal feeling, and it does not mean that you are having trouble. For the record, it took me, I started my computer science degree in, my bachelor's in computer science degree in, I think 2005, 2006, something like that, my bachelor's. I got C's and B's in my courses from basically until I was a junior. It took until I was a junior to start getting my first A's. So, and then I didn't have any confidence in myself as a programmer until about, 2014. So, but notice that confidence. I was getting A's in 2007 or so, 2008, but I had no confidence until 7 years later. And what I'm trying to say here is that especially in any of the sciences, you will suffer from something called imposter syndrome, where you think that everybody else is getting it. So, but you're not, and you're basically an imposter sitting in the classroom while everybody else is getting it. This is very common. It is not true. Please look at the number of people who were saying in chat that they did not get it. That was a lot of, I did not get it, or I had a lot of messages, and a lot of, I'm not getting it. Oh, wait, I think I have it. And that is perfectly fine, because this one was a bit of a big jump, but that's okay. Again, if you're not getting it, this does not mean that you're not cut out for it. Also, you could have more time. Nobody works great under pressure. But I decided rather than let you languish and try to do this, I'm gonna try to do it on your own and work on it for hours. I want to help you guys out with this. So first things first, let's go ahead and copy paste our first bit of code from here. Right? Import turtle, create our turtle with whatever name we choose. I'm going to go with Alice again. And rather than saying side, we're going to go with, right, we're asking the user for a radius. So anywhere I see side, I'm just going to replace it with radius. Yeah, I'll learn how to spell one of these days. I got my PhD in computer science, not English. But thank you, Ryan, for pointing out the typo. All right, so now here is the, an aside, by the way, if you ever find yourself having to take an English class for an elective like I did, longer story that I will eventually get into, my suggestion is take a Shakespeare class. Because that essentially becomes mandatory movie watching once a week. So much easier of a class because Shakespeare counts as literature, but you get to watch movies for a literature class. So try audiobooks. So now let's go ahead and do this. So the idea here is that the more sides we added on, the more circular this shape became. So let's just go ahead and experiment without the radius. Let's try to get this without the radius first. Like, let's just see what happens. For blank in range, let's see what happens if I draw a 20-sided shape. Okay, 20-sided shape is, let's go ahead. How much should my turtle go forward? Alice should go forward, let's say, 20. I don't know how big it's going to be. Alice dot forward 20. Okay, and then Alice dot, okay, if it's 20 Octagon, which however big that is, I don't know how big that is. Let's go ahead and do anybody, let's see. So that would be 360. Well, we want it to add up to 360 total, right? So what's 360 divided by 20? Oh, I don't know. I'm just going to make the computer figure it out, okay? All right, right? This is me being lazy over here, right? Math is hard. Don't do math. Make the computer do math. Okay. So let's go ahead. Again, this part doesn't matter because I haven't used radius, but let's go ahead and draw this 20 Octagon. That looks fairly circular. Okay. Also, you know, I could make it more circular, but notice I've got these two 20s over here. So I'm just going to say, so I'm just going to turn this into a variable. You don't have to do this part. This is just like something that I've gotten, you know, just hammered into my head that this is something to do. So rather than saying 20, I'm going to replace this with a variable. This will go sides amount of times. And then we'll do the amount of degrees I need to turn is 360 divided by sides. So here, right, that way I only have to change one variable here. Does that make sense to everybody? So yeah, couldn't do that because I didn't put anything. One, doesn't matter what the radius is, right? Does the same thing. All I did was replace our 20s with the variable sides. Is sides a constant? I'm letting, so it being all capitals means that we're going to treat it like a constant, meaning that once I set it, I'm not going to change it, is the idea. Or rather, I'm not going to change it later in code. So I won't change it, for instance, like after the for loop or I won't change it in line 9, but it makes it also so that I can change it once and then I don't have to worry about it. And now that looks a bit better. But notice is that we increase the sides. I'll talk about that a circle function more. So sides, 360 divided by sides. And notice that, by the way, as this went up, as we did more turns, right, this circle got bigger. So what we've got to figure out is, first off, if we've got this radius, how much, if we're doing like, let's say, sides number of turns, how big is this supposed to be? Well, the circumference, okay, so let's go ahead and figure out what the circumference is. I'm just being reminded of Terry Pratchett's Discworld, and that's a world on the back of 4 giant elephants that are on the back of a giant turtle. It's a great fantasy series. I recommend reading it. But anyway, to keep things from falling off the sides of the disc, you had the circumference around it. So let's go ahead and did I even spell circumference right? Circumference. So I missed an like I said. So I knew it was spelled wrong, but I didn't know how. Okay, circumference is equal to 2 pi r, right? So 2 times pi, we could import that, but honestly, I'm just going to be lazy and use 3.1415, which is close enough for basically the levels that's being stored in pi in Python, not really necessary. Okay, and then times the radius. So this is the total amount that we want to turn, that basically that we want to go around the circle, right? This is the total amount we want to go around the circle. So if we're doing sides number of turns, sides number of steps, then, so let's actually work with as a constant rather than, suppose we wanted to basically draw a circle by using 20 sides, okay? Always easier to go back to a constant rather than trying to think abstract in cases like these, right? If we've got 20 sides, then that means every time Alice moves, we want to move 1/20th of the distance. Does that make sense? Right, because the total circumference is this amount. We're going to be doing this 20 times. So each of these steps, we want to do 1/20th of that. Does that make sense to everybody? Yes in chat, no. Am I speaking to an empty room now? Okay. Somebody says no. Okay. So the idea here, okay, can I say it again? So the idea here is that we've got this radius. And the radius and pi is basically this part of this relationship that helps us figure out how big a circle is, sorry, the circumference is compared to the radius. So the idea here now is that we reuse the radius, we can calculate the circumference, which is how big around that circle is, right? This is the radius, the amount that goes to the center. The circumference is this amount. We figured out how much this is. If we are doing basically this by drawing a n-sided by a 20-sided polygon. If we're just saying this 20, we're going to pretend that this 20-sided shape is a circle. Okay? Everybody got that? We're pretending this 20-sided shape is a circle. So we know from the radius how big the circumference should be. Right? We know from the radius how big the circumference should be. And we also know that basically, if we're doing this 20 times, if we're drawing a 20-sided polygon, then we're going to be repeating this Alice.turnRight thing 20 times, and we're repeating the Alice.forward 20 times. So what is the appropriate amount to put in the forward? Because those are the two things we can change, the forward and the right. So we've figured out that the amount has to be, we just figured out from our previous examples that Alice.right, that is basically 360 degrees times the number of sides that you're drawing. So with circumference, we know that basically we want Alice to move basically 1/20th the amount of the total distance that she's going to be traveling. So if we do that now, let's go ahead and say a radius of 100. So that's how that breaks out like that. So now if we change it to 60, Alice will travel 1/60th of the distance each time. Don't worry if this was hard and you feel like you couldn't get on its own. In my opinion, this was this one is a bit of a, I feel like they needed an intermediary step over here, like to do n-side polygons, but notice that this looks fairly circular. I mean, you can see a bit of jaggedness, and that just might be the rendering on my computer, or it might be the rendering of the connection to you, but that's okay. It looks fairly circular. If you handed this picture to somebody and asked them, hey, what is this a picture of? And they would say, oh, that is a picture of a circle. They would not say, well, it looks like you drew an anagon, a 60-agon. Right? It's close enough to being a circle. And now, right, if we drew it up to 360, which is about as high as it can go, let's go ahead and do side 100, right? The reason this goes so slow, by the way, well, why is it going so slow as compared to the other ones?
Because it's doing more operations.
That's exactly right. It has to do 360 operations there. It's taking more turns. Right? It has all those steps that we need, that we're asking it to do. And it looks only marginally better than the 60-agon. So how do we do finally, how do we do the bonus part? Well, what we need to do is that to get it to start to draw it around that center spot, what we're going to do very quickly is have and I'll show you the answer and then I'll explain it. Alice.right 90 degrees. Alice, and I'm not going to drop the pen up so you can see the radius, by the way. Alice dot forward 100 degree, forward radius. And then Alice dot, actually, let's go ahead and do this as left. So Alice turns north, essentially, and then there. So that's all we need to get it to be at the center, I believe. I could be horribly wrong about this. Let's go ahead and do radius length of 100. So what this did is that this moved it north. So this area is going to be the center of the circle. So Alice moved north a radius amount, and so we just simply started up here instead of starting in the middle. If we need to move Alice down there, we just reverse our turns. We say, Alice, turn right to go down, move forward, right? In fact, we can do that right now. Alice, turn right, and then turn left. I will go ahead and share this code so you can have it, by the way. So I've shared this code for you, which means that you don't need to worry about frantically typing it down. You should be able to just load it up and run it on your end. Oh yeah, I forgot I can do this. There we go, that's probably better. So, but for those of you who do feel the need to frantically jot it down, I will leave it here for you. I'm not precisely sure how to access the shared code, to be honest. How do we see it if you share it? I assume if you hit refresh, then click on download, or reload history.
If you just like scroll back on the history, it'll show up.
Yeah. So make use of this bar and the buttons. I'm not precisely sure because I don't know what it looks like from the student's perspective over here. So the circle is working. Ah, yes. So this message, I think my code was right, but the circle is weird. Just FYI, everybody, code is not something we pluralize. It's just always kind of singular. Just an FYI, just to make it. No, it's no worries. So many freshmen do that. So, but if you say it like that, like in, let's say, a less hospitable environment, it may reflect poorly on you. So, okay, like my center is not really that centered. That's very interesting. So it is 3:18, which means this class is done. I'll be happy to take a look at those before I have demos. But for right now, class is dismissed. Be sure to fill out at the bottom how you felt about this. And then we will be working on and then we'll work on going into detail about how for loops work on Thursday. We're going to be looking at approximations of pi, and please feel free to bring pi to class. All right. Stop sharing. Stop recording.